All right, so we're going to pick up where we left off yesterday. We had gone over how you can find the inverse of a matrix yesterday using our Gauss-Jordan method, where we were looking for the identity matrix, so those ones to be in your diagonal and then the zeros everywhere. Else, what we're going to do today is talk about how to use an inverse to help us solve a matrix equation. So what this is going to look like is you're going to have a matrix, and we're still probably dealing with some of these larger matrices like a 3x3 matrix. And so all of these numbers, remember where they have like A1, B1, C1, and that, all of that came from your coefficients in front of your variables when you were looking at a system of equations. And then the X, the Y, and the Z, that's just going to be written off to the side. That's just going to remind us of where these numbers came from. And then the final matrix here where it says D1, D2, D3, that's going to be where your answers or your constants after the equal sign on those equations came from. To find our answer to solve this equation, we have to think about how we would solve for x. And so we can actually use the inverse, like what we did yesterday, to help us do this. So to solve for x, we would actually need to find the inverse of our matrix A and then take that times matrix B, and that would give me my solutions for those letters, for x, y, and z. So we're going to go through an example here. I've got this system given to me, so this x plus 2z equals 6, and negative x plus 2y plus 3z equals negative 5, and then x minus y equals 6. And so what they're doing is they're first grabbing all the coefficients, so the numbers in front of the x's, the numbers in front of the y's, and the numbers in front of the z's, and they're putting that here. So that's where all of those numbers came from. Those are all the coefficients in front of your letters. And then they're putting just next to it here x, y, and z to represent those letters from our equation. And then the 6, negative 5, and 6, those all came from after the equal sign. So this is kind of how we're taking this system and we're rewriting it as 3 separate matrices. The first step that we need to do is find the inverse of A. So this is what we did yesterday. So we're going to start with this matrix here, and we want to, again, switch our identity matrix around. Like we want everything over here, we want that to now look like that on the left-hand side, and then whatever we're left with on the right will be our new inverse. Okay, so this is what we ended class with yesterday, so we're just going to pick up here. So remember what we talked about yesterday is I would want to start by making sure that that first number is a 1, which it is, so I don't need to do anything with that one, but I need to make this one a 0. So how can I make that a 0? We could just take row 1 plus row 2. Okay, so if I do that, I would have a 0, a 2, 5. Let me scoot that over a little bit. Otherwise, I'm going to run out of room if I don't write small enough. And then 1, 1, 0. And then the top and bottom rows stay the same. Okay, now we would want to think about how do we make this become a 0? How could we do that? Yeah, we could just take row 1 minus row 3. So that would become 0. Now watch your signs on this next one because it's 0 minus negative 1. So that's going to become positive 1. 2 minus 0 is 2. And then 1, 0, negative 1. And then again, row 2 stays the way it is, and row 1 stays the way it is. Okay, so that first column is good. It says 1, 0, 0. So now we move on to the next term or next element that we would want to isolate or try to figure out what we can do here. So I'm going to focus on this 2. I want to make this become a 1. Okay, how could I make that become a 1? We might have to get a little more creative with this one. I think for some students, their first instinct is to want to take the last row times a -2 and add that. But remember, that would make it become a 0, and we don't want a 0. So I think that's kind of a maybe like a mistake that kids would make a lot, is they're trying to actually make something become a 0 when they're meaning to make it become a 1. So you're just going to want to watch out for that. So what I would probably recommend that you do is take 3 times row 3 and then subtract row 2 from that. And that should get me to a 1 here. And it should not impact the 0 at all either, because 3 times the 0 from the bottom row plus 0 is still just going to be 0. And then 3 times 1 is 3, but 3 minus the 2 makes that become a 1. And then 3 times 2 is 6. 6 minus 5 is 1. And then 3 times 1 is 3, minus 1 would be 2. And then we'd have -1. And then we'd have -3 minus 0, which would be -3. So that should be my new second row. And then the first row and the last row stay the same. Okay. Now I want to make this become a 0. How can I make that 1 become a 0? And still maybe try to think, is there a way we can do it so we don't impact the 0 at the very front? So maybe we don't want to use row 1 if we can help it. Okay, so let's just take row 2 minus row 3, or you could do row 3 minus row 2. It doesn't really matter there. But so that new row here is going to say 0, 0, -1, 1, -1, and then -2. Okay. All right, so I'm seeing 1s in my diagonal. That's really good. This last one is a -1, so it may be wise if we try to make that become a +1, maybe on our next step here. But I also, so I'm just going to circle this for a second. But I also want us to focus on how can we make this become a 0. Yeah, if we add row 3 and row 2 together, that would make that become a 0. So I'm going to write row 2 plus row 3. So this would be my middle row here. So it'd be 0, 1, 0. And then 1 plus 2 is 3. -1 plus -1 is -2. And -2 plus -3 is -5. Now, what I'm also going to do on this step, just because I can, is I'm going to switch the signs on the bottom row. So I'm just going to take a -1 times row 3. That way it just fixes that for me, and then I don't have to worry about trying to change that. So if you are getting a little bit more comfortable with your Gauss-Jordan process, you can start to do like multiple operations, like manipulate multiple rows at one time. You don't have to do that. So if you're still not quite there, you feel like you're going to make a mistake when you do that, then don't feel like you have to do all of that in the same step. You can kind of split it up into these 2 separate matrices if you want. I only did that because, one, I'm kind of running out of room. I've got one last matrix here on my outline, so I want to try to make sure I can fit it in. But so the last thing that I need to think about is this. How could I make this 2 become a 0? Yeah, if we take -2 times row 3 and we add it to row 1, that should cause it to become a 0. So -2 times 0 is 0, plus 1 is 1. And then this next one is just zeros. Then you'd have -2 plus 2, which is 0, which is what we want. Okay, and then the last couple of numbers here, so you'd have 2 plus 1, which is 3. -2 plus 0, which is -2. And then -4 plus 0, which is -4. And then everything else stays the same. So now if you look at what's written down here, this inverse matrix, okay, this got put here. Now, where did this one come from? Yeah, that came from up above, right? So back up here when we started it all out, these numbers 6, -5, and 6, those all came from there. And if you remember when we started at the beginning, in order to find the answers for your x, your y, and your z, so again, we're kind of finding another way to solve our system of equations here, is you're going to take the inverse that we just found times this. We're going back to matrix multiplication. Remember how we would multiply matrices? Is you would take the row times the column. So you're going to take these numbers times my column here, and then you're going to add all of those together. So I'll just write off to the side here what that's going to look like. You're going to take 3 times 6 plus -2 times -5, and then plus -4 times 6. So you're multiplying, and then you're just adding all of those together. So this would be 18 plus a -10, or sorry, plus +10, and then plus a -24. So you should have 4 left over. Then for the next pairing, you do this row times this column. So 3 times 6 plus -2 times -5. It's looking the same so far, but this last one's going to change a little bit. It's -5 times -5. So this would be 18 plus 10 plus 25. Okay, hold on a second. I just realized I put the wrong number here. So that should be 6. I was looking at the 5. Okay, so -5 times 6. That should fix it. So this is 18 plus 10, so that's 28. And then this is -30, so that would leave me with a -2. And then your last one is the last row times this column here. So -1 times 6 plus 1 times -5 plus 2 times 6. So this would be -6 plus -5, so that's -11, and then plus 12, which would leave you with a +1. So your final answer here is this, but again, we're thinking about order triples, so it'd be 4, -2, 1. So this is similar to like in chapter 5 when we were solving a system of equations with 3 variables using substitution or elimination. This is similar to that Gauss-Jordan model that we used at the beginning of this chapter. So it's just another way that we can solve this complex system of equations still using our matrices though. All right, so if you turn your page over, we're going to try one. So this one, kind of led us a little bit. We're going to try one now from scratch. And I'm gonna give you a couple of minutes to try to see what you can do here. I'm going to help you get it set up, and I'll give you a little bit of time to try to work through it. And then I'll probably just start working through it on my own. So you can kind of like keep track of how you're doing and maybe what I'm doing. But remember, what we're going to do is take all of our coefficients. So all my x's are 1, 2, 3. My y's would be a 0, a 1, and a 4. And your z's would be 5, 6, and then a 0. Remember, if it's missing a letter in the equation, then it's a 0. Okay, and then this is going to be times x, y, z. And this is going to be equal to 0, 1, 3. Okay, so to get yourself started, you want to write out your first matrix. And then we want the identity matrix on this side. Okay, so remember, your goal is to get the identity matrix to be on the left-hand side now. Okay, so I'm just going to give you a couple minutes to maybe get a jump start on this, and then I'm going to probably start to quietly work through it up here. And so you can follow along as I kind of start to work through it, or you can keep going with yours if you feel like you're on the right track. Okay, but try to do something with it. I know this is not necessarily your favorite thing to do, But the only way that we get better is if we try to do it ourselves. So I'm going to give you maybe like 3 minutes to get started on this, and then I'm just going to start slowly working through it on my own, and then you can kind of see how we get to our final answer. Okay, if you're still working and if you're feeling confident about what you're doing, I want you to keep going. Okay, I'm going to start to silently work through this up here. So if you got stuck, you can kind of follow along with what I'm doing. I'm not going to talk all the way through it here. I'll probably start explaining what I would do at the very end once I get to my identity matrix on the left-hand side. Okay, so that's how I kind of would have worked through that on my own. Now, if you went about this a different way, you maybe can still get to the same identity matrix if you followed a different order of operations, okay? But now to finish it off, we need to take, we need to take this side and we need to multiply that times from the beginning of our problem, way up here when we wrote this out. We need to take it times the 0, 1, and the 3. Okay, so using matrix multiplication, we're going to do that. So we're going to take those rows times the columns, and that's going to give us our answer here. Okay, so if you're to this point, and even if you weren't able to get there all the way, like you got stuck or something, hopefully you can kind of follow what I did there. But I'm going to give you here like a minute. I want you to go ahead and multiply those matrices to get your final answer. Okay, so hopefully you had a minute to multiply those. You should have had 5, -3, -1. And so if you want to write it as an order triple, it would look like this. That would be the system, the solution to the system of equations that we had up above. So that system that we started at the very beginning, if I was using matrices, if I was using our substitution or elimination methods from the last chapter, you should get that as your final answer. 5, -3, or +1. +1, not -1. I think I wrote that wrong. Oh, one of them. Hold on, I got it written down twice here. Let me think. 0, -4, 3. Yeah, so it should be -1. Okay. All right, the last thing I want to go over on the last page here is how we can use matrices to either encode or decode messages. So the reason why we would ever need to use a matrix to like decode a message, in like the military field, a lot of times when they're communicating to each other, like across ways or whatever, if they're trying to send messages to each other, they're going to use codes or they're going to use like a different language almost when they're trying to communicate. So especially like way back, when it was primarily like Morse code was used a lot to communicate amongst things, and not even just like in war, but like ships were using Morse code to communicate with countries and stuff like that, like where they were at or things that they were running into when they were maybe sailing somewhere. But in the situation of like war, if they were going to send a message to another group that they were trying to communicate to, they're not just going to say in their message, hey, we're planning on attacking this country on this time on this day. Like they're not going to give all that information out because anybody could be taking those messages or like listening in on those messages or listening in on those conversations or trying to like intercede like the Morse code messages that they're sending each other. So they would use like a code language to communicate with each other. And so sometimes there would be people who would need to look at the messages that they were receiving and try to figure out, what is this code for? What are they really trying to communicate to each other about, so that we can try to break the code and see like what are they planning, right? So when we talk about matrices, we can use a matrix to help us decode messages. I'm going to show you how to do this. So I'm going to assign numbers to the letter of the alphabet. So I have all the letters A through Z numbered 1 through 26. And then blank, I'm going to assign as 0. That would mean like if there was a space, or if maybe there was like something that didn't seem to match up with one of my letters, it would probably be representing something that didn't have a letter attached to it. Okay, so I'm going to show you how we would code and then be able to decode my message. So somebody like me who has the first name of Elizabeth, I'm going to look at my first 4 letters of my name, so E, L, I, and Z, and I'm going to look at my assigned numbers up here, and I'm going to write a matrix using my letters. So E is a 5, so I'm going to put 5 there, and then L is a 12, and so I'm going to put that next to it. And then the I and the Z, I'm going to put on my second row so that I'm making like a 2 by 2 matrix here. So I is 9 and Z is 26. Okay, so these would be like, this is my original message that I'm trying to send to somebody. Now I'm going to use this matrix up here to help me make this become a little bit more cryptic so that if somebody were to find this message somewhere, they wouldn't know what I was trying to say. So I'm going to multiply it by this matrix 0, 1, 1, 1. And then we do our matrix multiplication. Okay, and we've done this enough times now that we kind of know the drill. You're going to take 5 times 0, 12 times 1, you're going to add those and you get 12 for your first entry. Then you're going to take 5 times 1 and 12 times 1, you're going to add those and you get 17. Okay, what would the bottom row say? Good, 26 and 35. Okay, so this would be my coded message. This would be maybe what I would send out, and then the person that I'm communicating to would understand that I used this code and they would be able to decode it on their own. Now, if somebody intercepted this message and they were trying to break the code and they know that I'm using this matrix 0, 1, 1, 1, because of previous messages, they've kind of discovered this pattern between the messages that I'm sending. They can now decode this by using the inverse. Now, the inverse of this matrix, so this is just a 2 by 2. So remember, you would like interchange your rows, you would change some of your numbers, you would find your determinant. So that's what they're doing here. And they got this as my inverse matrix. So if we find the inverse here, we can take that times the message that they received. So the message that they got is 12, 17, 26, and 35. And they know that the matrix I'm using was that 0, 1, 1, 1. So they're going to use the inverse to code it back. So we're going to take this times the inverse matrix. And then we're still going to do the same thing. We're going to multiply rows times columns. And when we do this, we should get back to 5, 12, 9, and 26. And so then whoever was looking at this would now know what I'm trying to say. Because if they can find the pattern that you're trying to use, and this would take some time, like they would have to look at a lot of messages that were being sent back and forth and be able to figure out similarities between the messages. Is there something that seems to show up a lot so they can kind of break the code that they're using to kind of scramble the letters in a sense? And then they can use the inverse to get it back to what they started out as originally, so that they would know what the original message was. So if you'd like to practice this, you can kind of do these 2 on the bottom. You can write out the first 4 letters of your name. If you don't have, like if your name is only 3 letters long, you could just put in like a 0 for your last number or for your last letter if you wanted to. Leave it like blank. And then if you want to practice again, you can look at the person next to you, figure out what their name would be, and like do the same process. So I'm going to kind of leave that up to you if you want to practice doing that. There will be some problems on your homework that ask you to kind of encode and decode messages, so you'll get a little bit more practice there too.